Hi class, in this video I am going to explain how to use method of characteristics to solve a partial differential equation. To solve an equation using the method of characteristics, we assume that u is a function of x and t, and that x is also a function of t, which we have written right here. We use this as our ansatz to solve for u of x and t. If we take the full derivative of u, we get du dt equals partial with respect to t plus dx dt times partial with respect to x. We can then go ahead and match our given partial differential equation with the equation we have here to come up with an equation in the form u of x and t. The example we're going to go through, it was question number 2 from midterm number 3 in 2014. Our equation given is partial with respect to t minus 4t times partial with respect to x equals u, with the initial condition u of x at t equals 0 equals e to the negative x squared. By lining up the given equation with the equation for du dt that we derived on the previous slide, we can easily see that du dt is equal to u and that dx dt is equal to negative 4t. Note that if we had a coefficient in front of our partial with respect to t, we would have to divide the entire equation by this. Alright, let's move on. So now, we want to solve the two ordinary differential equations we came up with using separation of variables. We are going to start by solving for x in terms of t. Here we had dx dt equals negative 4t. Using separation of variables and integrating both sides, we get x of t equals negative 4t squared over 2 plus a constant. We now want to substitute t equals 0 to find x naught, because we will need this later when we use our initial condition. Doing this, we see if we substitute t in for 0, we get x naught is equal to c. Therefore, x of t equals negative 2t squared plus x naught. Our next step is to solve du dt equals u. Dividing both sides by u and integrating both sides, we arrive at the equation u is equal to c times e to the t. Before finishing, we must solve for this constant c. To do this, we will apply our initial conditions. Our initial conditions given before were u of x at t equals 0 equals e to the negative x squared. If we substitute t in for 0, if we substitute 0 in for t, we get u is simply equal to c. Therefore, c is equal to e to the negative x naught squared. Putting this all together, we get u of x and t is equal to e to the negative x naught squared times e to the t. Here we just substituted back into this equation that we derived before. Now remember, when we solved the equation dx dt equals negative 4t, we determined that x equals negative 2t squared plus x naught. Rearranging this equation, we get x naught equals x plus 2t squared. We can just simply substitute in for x naught to get our final equation of u of x and t is equal to e to the negative x plus 2t squared times e to the t. Or we can rewrite this as u of x of t and t equals e to the t minus x plus 2t squared.